Hello everyone, my name is Dr. Yogesh Valla, and today we are going to start or discuss the topic of homogeneous differential equations, that is the type 3 in case of ordinary differential equations. Now before starting this topic of homogeneous differential equations, first of all we will discuss what do you mean by homogeneous. So let us suppose we have a function f of xy. Now I'm saying that this function is homogeneous in x and y. What does it mean? If I can express this function in the form of x is to power n phi of y upon x, then I can say that this function is homogeneous. Basically what I need, let us suppose I have a function x cube plus y cube plus 3x square y plus 3xy square. Now just check, the index of first term is 3, the index of second term is 3, index of third term is 2 plus 1 3. Here it will be 1 plus 2 3. That means throughout the equation the index is 3. So I can take x cube common. It will be y 1 plus y cube over x cube plus 3 times. If I take x cube common, so x cube will be cancelled out, we get y upon x plus 3 times y square upon x square. That means every term in this bracket is expressed in the form of y upon x. So it can be an x cube function of y upon x. So it is a homogeneous function in x and y of degree 3. So basically homogeneity means this thing. Okay. So homogeneous differential equation means a differential equation of the type dy by d of x is equal to f1 xy comma f2 of xy, where f1 and f2 both are homogeneous functions in x and y of degree n. Okay, in such type of differential equation, the step 1 will be, we need to substitute y is equal to vx such that dy by dx is equal to v into derivative of x will be 1. Now x as it is, derivative of v will be dv by dx. And when I substitute these values in this differential equation, then after that I need to apply variable separable form. Whatever be the result over there, after that we have to substitute the value of v from this part, that is v is equal to y upon x in the given, in the solution part. Okay, that will be your final solution. Let us take a question, for example. So the question is, solve 3xy square minus of x cube into dx minus 2 times x square y minus xy square dy is equal to 0. Okay, so this is the question which we have to try now. So solution part for this one, first of all I need to check whether it is a homogeneous or not. So this will be of 1 degree, this is of 2, 2 plus 1 3, this is 3, 2 plus 1 3, then 1 plus of 2 3. That means this equation is homogeneous. So it is a homogeneous differential equation, and it can be written as 3xy square minus of y cube into dx is equal to 2x square y minus of xy square dy. Okay, now I need to write in the form of dy by dx. So 3xy square minus of y cube divided by 2x square y minus of xy square is equal to dy by dx. What I did, I take this part to the denominator of this one and dx on the other side. Okay, now I need to substitute y is equal to vx such that dy by dx is equal to v into derivative of x will be 1 plus x as it is, derivative of v will be dv by d of x. Let be equation number 2 and this is my equation number 1. Now from equation 1 and 2, from 1 and 2, so dy by dx, that is v plus x dv by d of x is equal to 3x y square. Y square means vx whole square minus y cube, that means vx whole cube, divided by 2x square into vx minus of x into vx whole square. So 3v square x cube minus of v cube x cube divided by 2vx cube minus of v square x cube. I can take x cube common. It will be 3v square minus of v cube divided by x cube common. So it will be 2v minus of v square. So these two terms cancelled out. X dv by dx is equal to 3v square minus of v cube over, I can take v common as well. Okay, so I'm taking a v common. So it will be, if I take v common, so it will be 3v minus of v square divided by, if I take v common, 2 minus of v. Now v also cancel out. And I'm taking this v to the side, so minus of v over 1. So x dv by d of x is equal to 3v minus of v square minus v times 2 minus of v over 2 minus of v. So x dv by d of x will be 3v minus of v square minus of 2v plus v square over 2 minus of v. So plus v square minus v square cancel out. So x dv by d of x is equal to 3v minus 2v, v over 2 minus of v. Now I need to apply variable separable form. So it will be 2 minus of v over v into dv is equal to dx over x, and integrating both sides, so it will be 2 minus of v over v into dv is equal to integral of dx over x. So integrating both sides, what I got, 2 upon v means 2 times log v minus v upon v 1, integration of 1 will be v is equal to integration of 1 upon x will be log of x plus log of c. So it will be log v square minus of v is equal to log of x into c, log m plus n property, that is log m into n. Now it will be log of v square minus log of xc is equal to v. So log m minus log n, so it will be log m over n. V square over xc is equal to v. Now what I need to substitute v is equal to y upon x. So the value for this one comes out to be v will be y square upon x square upon xc is equal to y upon x. So log y square over x square into x cube c is equal to y upon x. If I take anti-log, so it will be y square upon x cube c is equal to e raised to power y upon x, or I can say y square is equal to x cube c into e raised to power y upon x. This is the final answer for this question. Okay, I think so concept is clear to everyone. I'm taking one more question for the clearance of this topic. So the question is, solve x times tan y upon x minus of y times secant square y upon x dx plus x times secant square y upon x dy is equal to 0. Now if I check about the degree, so it will be of 1 degree. Y upon x is single angle, it is a 1 degree, it is a single angle, 1 degree, it is a single angle. So that means we are having a differential equation of degree 1. Okay, so it is a homogeneous differential equation. It is a homogeneous differential equation, and I need to rewrite it in the form of dy by dx. So this equation can be x tan y upon x minus y times secant square y upon x into dx is equal to x times secant square y upon x into dy with a negative sign. Now it will be x times tan y upon x minus y secant square y upon x over minus of x into secant square y upon x, and that will be equal to dy by dx, or I can say dy by d of x will be, I am adjusting this negative sign over here, so it will be y times secant square y upon x minus of x times tan of y upon x upon x secant square y upon x. That will be equation number 1. Now as per the condition of homogeneous, I need to substitute y is equal to vx such that dy by d of x is equal to v into 1 plus x dv by d of x. That's equation number 2. So from 1 and 2 we get v plus x dv by d of x is equal to y will be vx into secant square vx over x minus of x tan vx over x divided by x into secant square vx over x. X cancel, x and x cancel, x and x cancel. So we get vx dv by d of x is equal to vx. So I'm taking x common. So v secant square v minus of tan v divided by x into secant square v. So this x and x cancelled out, and x dv by d of x will be equal to v times secant square v minus of tan of v divided by secant square v. Now I'm taking this v on the other side, minus v upon 1. So it will be v times secant square v minus tan v minus v times secant square v over secant square v, that is x dv by dx. So this part and this part both cancelled out. So it comes out to be x dv by d of x is equal to minus of tan v over secant square v. Now I will apply variable separable form. So it will be secant square v over tan v into dv is equal to minus dx over x, and integrating both sides. So it will be, now applying the property of integral f dash x over f of x dx, that is equal to log of f of x. So it will be log of tan v is equal to minus log of x plus log of c. So it comes to be log of tan v is equal to log m minus log n log c over x, taking anti-log on both sides. So tan v is equal to c upon x, or we can say v is equal to tan inverse c upon x. Now this is not the answer because our question was in terms of y and x, not in terms of v and x. So I need to substitute v is equal to y upon x. So y upon x is equal to tan inverse c upon x, or we can say y is equal to x times tan inverse c upon x. So this is our final answer for this question. Hope it is clear to everyone. Okay, I am taking one more question. So question is, solve 1 plus e raised to power x upon y dx plus e raised to power x upon y 1 minus of x upon y dy equal to 0. Now just check here, instead of having y upon x, I am having x upon y. So in such type of questions, we will not be having a statement of dy by dx. Instead of this, we will be having the statement of dx by dy. Okay, there is a small change in the form of the questions. So solution for this one, so first of all I need to separate both of the terms. E raised to power x upon y dx is equal to minus of e raised to power x upon y 1 minus x upon y dy. So dx upon dy is equal to minus e raised to power x upon y 1 minus x upon y over 1 plus e raised to power x upon y. I can adjust this negative sign inside, so e raised to power x upon y minus 1 divided by 1 plus e raised to power x upon y dx by dy, and let it be equation number 1. Now instead of substituting y is equal to vx, I'll substitute x is equal to vy, or we can say x upon y is equal to v, such that dx upon dy is equal to v into 1 plus y as it is dv by dy. That is our equation number 2. So from 1 and 2, so from equation 1 and equation number 2, dx by dy will be v plus y dv by dy is equal to e raised to power x upon y, and we know that x upon y is v, so it will be e raised to v minus 1 over 1 plus e raised to power v. Now I'll take this term on the other side, so it will be y dv by dy is equal to e raised to power v minus 1 over 1 plus e raised to power v minus of v by 1. I am taking LCM and now expanding the brackets, e raised to v into v minus e raised to power v minus of v minus e raised to power v into v divided by 1 plus e raised to power v. So this and this cancel out, we get y dv by dy. So it will be y dv by dy is equal to minus e raised to power v plus v over 1 plus e raised to power v. I know that derivative of y is always 1. Okay, so first of all I need to apply variable separable form, so it will be 1 plus e raised to power v over v plus e raised to power v dv is equal to minus dy over y. Now derivative of v will be 1 and derivative of e raised to v will be e raised to v. Integrating both sides, so integral 1 plus e raised to power v over v plus e raised to power v dv is equal to minus integral dy over y. So again the formula will be there, f dash x over f of x, so it will log of v plus e raised to power v is equal to minus log of y plus log of c. So log of v plus e raised to power v is equal to log of c upon y. Taking anti-log on both sides, we get v plus e raised to power v is equal to c upon y. Now what was the value of v? Basically v was x upon y. So x upon y plus e raised to power x upon y is equal to c upon y, taking LCM respect to y. So x plus y e raised to power x upon y is equal to c. So this is our final answer for this question, and I hope that everyone understand the concept. So I'm just briefing once again. So in homogeneous differential equation, what I need first step is to check whether the degree of all the variables in throughout the equation is same or not. If it is same, so I need to represent in first step that dy by d of x in the form of something, and then I need to substitute y is equal to vx such that dy by dx is equal to v into 1 plus x dv by d of x. Then I need to apply variable separable form and integrate, and then I need to integrate. After integration, I need to resubstitute the value of v is equal to y upon x from this part. Okay, that will be the final answer for these questions. That's it for today. Take care. Goodbye.